All right, how are we? I've been told to start prompting people to like and subscribe and leave a comment if you've got any questions. So, you know, do that if you've got time. So we're going to go through a vector question. This one is extended response. It has three parts, and these three parts are about this information. So our first part, we need to find the vector OA and the vector CA in terms of the unit vectors and this root lambda. So we have a tetrahedron, and we know that OB is equal to the unit vector I, OC is equal to negative I plus 3j, and we know that BA is equal to lambda k. I've just noticed a problem. There needs to be a tilde underneath that I so that everyone knows it's a vector. So let's start this A. We want to express this vector OA. We'll do this in purple. So OA, so we want to get from O to A. So to get from O to A, we can first go from O to B and then from B to A. So the vector OA is equal to OB plus BA. Now we know OB, that's fantastic. And we can look at this BA and realize that B to A is given here. Okay, so from that, we're able to say that OB is equal to vector I plus BA, which is root lambda vector k. All right, now we need CA. So let's look at the journey we have to take. So to get from C to A, we need to get from C to O, and then from O to A. And we know O to A, so that's good. We already have that. So we need CO plus OA. Now, we know OC, so OC is negative I vector plus 3j vector. So that means that CO is the opposite direction. So CO will be positive I vector minus 3j vector. And we're adding OA, so we're adding I vector plus root lambda k vector. So this becomes 2 times vector I minus 3 times vector j plus root lambda k. All right, so that is the first part of the question. Let's shrink it and move it. Oh dear, it's all right, undo. Let's try that again. Let's resize it. Yes, let's shrink it down, check it there, and ask for that later. Now, B, we want to find the angle CBO to the nearest degree. So the angle CBO is this angle here on the base of our tetrahedron. So let's think about what we can do here. We want, let's do that in yellow, we want this angle here. Now we're going to use our dot product. So for B, we want angle CBO. Now what we can do here is we can call angle CBO theta. We'll call that theta. And what we're able to say now is that the dot product of BC and BO is equal to the magnitude of BC times the magnitude of BO times the cosine of theta. So that's our definition of the dot product. So we can write down BC, we can write down BO, we can find their magnitudes, and then we can do our calculation. So let's find BC. So vector BC, if if we look at this diagram, vector BC is equal to BO plus OC, which BO is negative I vector, and that's because if OB is I vector, then BO is negative I vector. And then we take away I plus 3j. So let's have a look at that. So we know OC. We're given that as part of the question. So we can simplify that. So BC is negative 2I plus 3j. Okay. BO, we just know, we're given OB is I, so BO is negative I. Now we need our magnitudes. I like to get everything found first. Let's make that more obvious. That's a B. Oh, that's terrible, sorry. B, that's better. And we'll fix this one up too. Alright, so I like to get my magnitudes down first. So my magnitude of BC vector is equal to the square root of negative 2 squared plus 3 squared, which is the square root of 4 plus 9, which is the square root of 13. The magnitude of BO is just 1. Okay, we don't need to do anything fancy there. Alright, now we plug all of this into our dot product formula. Let's actually change colors for this. Boom, boom. And we'll do this in a peach color. So the dot product, so let's say BC is negative 2I plus 3j dot negative I, and that's equal to the square root of 13 times 1 times the cosine of theta. So when we're calculating our dot product, we do the sum of the products of each vector. So negative 2I dotted to negative I will give us 2. And that's going to equal root 13 cosine theta. That's an implication. Alright, so the reason the j cancels is because there's no j in this vector. Okay, so this dot product doesn't contribute. So now I can say that the cosine of the angle is 2 over root 13, which means that our angle is the inverse cosine of 2 root 13, which is approximately equal to 56 degrees. Okay, and that's rounded to the nearest degree. I didn't do anything fancy there. Okay, so I just did that in my calculator. So let's isolate these guys. Let's shrink them. And let's put them over here because we don't need them for the next part. Okay, now we want to find lambda if OAC is equal to 30 degrees. Now OAC, so that means we're looking at this angle here, and that's 30 degrees. So again, we're going to use our dot product for this. Let's do this in blue. Actually, let's do this in white because it's kind of the headlining question. So we're looking for this angle, so we use the fact that AC dotted to AO is equal to the magnitude of AC times the magnitude of AO cosine of 30 degrees. All right, so AC is going to be equal to negative CA, and we found that. So let's just make a note of that. AC equals negative CA, and AO equals negative OA. Boom, boom. And we found them in our first part. So AC is negative CA, is, so what we're finding the dot of negative 2i vector plus 3j vector minus root lambda k vector, and that's being dotted to AO, and AO we found to be, so it'll be negative I vector minus root lambda k vector. Okay, so give that a second to sink in. And now we equate these to the product of our magnitudes. So the magnitude of AC is going to be the square root of the I component of AC squared, so that's negative 2 squared, plus 3 squared, plus negative root lambda squared. And then we multiply that with the square root of OA, so that will be negative 1, so the magnitude of OA, plus negative root lambda squared. And, well, let's just go straight here. The cosine of 30 degrees is root 3 on 2. Because this is extended response, you can absolutely do that on your calculator, but I recommend knowing those exact values. Okay, I try hard to get my students to understand where they come from using the triangles, or if they don't have too much imagination, they can memorize that table, but I use the exact value triangles. All right, so let's take our dot product. So we have an I component, so we multiply the I components. There's no j component here, so this cancels. And then we multiply our k components. So our dot product will be 2 plus lambda, and that will equal to the square root of, where are we? This will be 4 plus 9 plus lambda times the square root of 1 plus lambda times root 3 on 2. Now I'm going to be a little bit cheeky here. I'm going to move this 2 across. So we're going to have 2 plus lambda equals the square root of 13 plus lambda times 1 plus lambda. So here I took advantage of the fact that root A, root B equals root AB. Now I'm going to square both sides. Oh, no, what have I forgotten? That's all times root 3. So I'm going to square both sides. So square all of that, and I'm going to square all of that. And that gets rid of those square roots. So I'll get 4 times 2 plus lambda all squared equals 3 times 13 plus lambda 1 plus lambda. All right, let's expand all of our brackets. So we'll first expand brackets and then we'll go into those brackets. So this becomes 4 plus 4 lambda plus lambda squared, and that comes from the fact that a plus b all squared is a squared plus 2ab plus b squared. So I encourage you to know that expansion trick there. And this one I'm going to FOIL. So 13 times 1 is 13. 13 times lambda is 13 lambda. Lambda times 1 is lambda. And lambda times lambda is lambda squared. So I'm going to expand these brackets here, boom, 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 and that will give me 16 plus 16 lambda plus 4 lambda squared, and this is going to be 3 times 13 plus 14 lambda plus lambda squared. Okay, you absolutely could skip this step. If you can see that that's 14, you can expand straight away and take advantage of that if your arithmetic is good enough. Mine isn't, so I tend not to. So this stays 16 plus 16 lambda plus 4 lambda squared, and I get 39 plus 42 lambda plus 3 lambda squared. 3 times 14 is the same as 6 times 7. So halve one, double the other, and that lets me do that by inspection. Now I'm going to do some sneaky arithmetic. So I'm going to take 3 lambda squared from both sides, take 3 lambda squared. I'm going to take 42 lambda, take 42 lambda, and I'm going to take 39, take 39. So that's going to give me 16 minus 39 is negative 23. 16 minus 42 is negative 26 lambda, and 4 minus 3 is 1. And that's all going to equal 0. That's a squared right there. So it's an extended response question, so I solve this with my CAS. Okay, so I'm not going to go through how to do that on your CAS in this video. If you want CAS support, let me know. I'm happy to go through CAS stuff for you. I use the Casio ClassPad, but they map pretty well to each other. So from this quadratic, I get lambda equals 13 plus or minus 8 root 3. But that's 2 numbers. I only want 1 number. Now we go back to our definition and we see that in our original case, BA is the square root of lambda. Okay, so lambda has to be a number that has a square root, which means lambda is greater than 0. So for this question, lambda is 13 plus 8 root 3. Okay, this question would be very at home in exam 2. It also, this last part would be perfectly accessible in exam 1. So you do need to be able to solve this sort of quadratic. If you want to go through one of these quadratics, let me know. I've got a survey in my channel info where you can submit questions, or just leave a comment below with that you want to go through some quadratic equations, and I'm very happy to do that. All right. I hope that was useful. Good luck.